Hi, in this video, we will see what are all Kubernetes taints and tolerance on AWS EKS cluster with using Karpenter. As you might have heard words like taints and tolerance in Kubernetes, taints and tolerance are used to control which pods are scheduled on which nodes. So basically, taints are labels that are applied on the nodes to indicate that certain parts should not be scheduled onto those nodes unless they have a corresponding tolerance, right? So here what we see is, we see this concept at a practical lab session here, right? So what I do is I'm going to give you a proper end-to-end lab session on how does Kubernetes taints and tolerance works. So in this demo, what we do is we're going to see that we create an Amazon EKS cluster. In that one, we're going to host a Karpenter. So basically, Karpenter is nothing but an additional infrastructure layer, which actually manages the lifecycle of Kubernetes application on the EKS cluster. So with using Karpenter, we will study what are, how does taints and tolerance works on the Kubernetes level, right? So with, when I say taints and tolerance, basically as part of this demo, we're going to deploy the Karpenter node pool, which are having configured with the taints something like this, that is key equal to system node and effect equal to no schedule, something like this. Right now, after that, we deploy a pod which does not has any tolerance to this particular taints, which means that pod becomes unschedulable, in the sense it becomes basically pending. It goes in a pending state because it does not has any hosting places where it can be hosted, right? So then we will also see another scenario where we define the pod or basically a deployment with a certain tolerance definition in a such a way that it will be tolerated to the taint with a key name called system nodes. Okay, so in such cases, that pod will be qualifying for to be scheduled on the nodes that is created by Karpenter. Okay, so basically in a layman term, this is what the demo going to be shown in this video, right? So with that note, let me take you to the my Visual Studio Code. So this is my Visual Studio Code. So in this one, I have articulated all the files and folders that is needed for this demo purpose. So if you see here, I have a folder called taints, and underneath that I have a help file. So in this help file, I have already articulated the steps that you need to follow to try to mimic this scenario from your side to learn more about what are taints and tolerance in Kubernetes. Right. Along with that, I have also have few YAML files, which is basically creates the few resources like Karpenter node pools. The other one is the the example application deployment on the EKS cluster. All right, so these are the basically prerequisite here. Now, so I'm going to share this these files and folders in the video's description via my GitHub repository link, right? So I will store these the files and folders in my GitHub repository. The link of GitHub repositories will be shared in my video's description. You can find it from there. Now what I do is, so as part of this demo, I have already created a cluster. Right now, let me quickly walk you through those. Okay, so basically, so remember that here there are lots of prerequisites. The first number is, you need to have your system pre-configured with the certain software requirements, right? Here is, you need to have your system installed with the AWS CLI so that you can interact with the AWS CLI. You need to have your system installed with the EKCTL so that you can create a the EKS cluster with using EKCTL utility. And you also need to have your system installed with the kubectl command and Helm, further extra as well. So first one is, basically I'm using AWS CLI because my system is already installed with the AWS CLI. So using AWS configure, we basically setting a context of my AWS account with using the AWS CLI. And then here we are actually checking the context by using command AWS STS get caller identity. It reflected something like this, which means that it has set the context correctly. Now then next one is, create the cluster. So to create the cluster, I'm using cluster.yaml file. Okay, so I'm just going to show you that here. So basically this is create a cluster.yaml file. So this is here, basically we are creating an example, the cluster with the node group name like demo node group, and the instance type is t2.extra large. Minimum node is 2 and 4. So basically I'm using ekctl to create the cluster. So when I run this command pointing to this particular file, it has created the EKS cluster for me, and it has taken more than 10 minutes. Okay, so I don't want to waste your time here, so that's the reason I have pre-created the Kubernetes cluster here, right? So if I go back to my AWS account, so this is my AWS account. So this is basically my AWS account, right. So I'm currently in Oregon region, where my cluster is also been created. You see that Karpenter demo cluster is been created now. That is created through the EKCTL only. So basically, once the cluster is created, what I did is, so I will go to the help file. So in the help file, so what is there, what is here is basically, once EKS cluster is created, the next step is you need to install the EKS cluster with the Karpenter. So Karpenter is, as I said earlier, it is basically another, the application lifecycle orchestrating tool. So let me use the word something like this, which actually helps to manage the lifecycle of your application, which including like pod scheduling, making the pod highly available, right? So there are n number of capability that, there are like a huge, I'm sorry, not a n number, basically huge list of capabilities are provided by the Karpenter. So basically, and that's the reason I call it as an additional infrastructure layer, which orchestrates the application lifecycle, right? So to install that software, so it is basically becomes a prerequisite before try to evaluate the taints and tolerance in the EKS cluster, right? So I have a set of the commands which I have already articulated, and I have shown you in detail, like how to host the the Karpenter on the Kubernetes cluster. If you want to see in a very detailed manner, please try to watch my previous video. In this video, we're gonna go very fast. So here, once the cluster has been created, what I do is, I am doing a certain step to configure the Karpenter. So first one is, I'm just describing the cluster so that I can get the endpoint here, right? So once the endpoint is done, then basically we are actually setting these many variables, if you see here, right? And then what we are doing is we are actually deploying the cloud formation, which is actually creates a prerequisite IAM roles that is needed for Karpenter installation purpose, right? And once that has been done, we are actually creating the, basically, if you see here, we're actually creating the so here we are creating a cluster role here with using EKCTL. Remember that I'm not using kubectl, but I'm using EKCTL and creating an IAM identity mapping within the cluster, right? So and then you can describe that, basically you can get the kube config basically, yeah? So with using this EKCTL command, you are creating a config map, basically IAM identity config map within the cluster, something like that, yeah? So this is a here kubectl describe config map, and if you try to do this particular command, you're gonna get what you have created above. So once this has been done, the next command is basically, the associating the IAM identities, basically associating, OIDC provider to the cluster. Okay, so that is what this command will do. And then, we are actually creating the IAM service account for the cluster, right? And after that, basically again you are creating a variable that is Karpenter IAM role variable. Then creating a, the get, basically checking the, if you have created IAM service account in the cluster, from the cluster, right? So basically, does the cluster has the IAM service account, something like that, checks. And then we are setting a huge list of variables which is needed to install the cluster, which is needed to install the Karpenter on the cluster. So this is basically Docker logout public ECR. That is the basically a step that you need to perform, to install the Karpenter on your cluster. And then here is the final step, basically to install the, the Karpenter on the EKS cluster. So here we are using Helm charts to install the Karpenter on the EKS cluster, right? So and whatever the variables that we created above, so those are all the variables being consumed here. And then finally you should be able to see these many output, which actually tells you that, the Karpenter is installed on your system. To validate, you're gonna run this command, that is helm list namespace Karpenter, which actually should return something like this, which means that Karpenter is running. And check any pods related to the Karpenter applications are working fine or not. That is using command kubectl get pods namespace equal to Karpenter, because Karpenter Helm chart will create a namespace called Karpenter, remember that, right? And then get the deployment of the Karpenter. So basically I'm checking everything went good or not while installing the Karpenter, which means that, Karpenter is now steady, in the sense Karpenter is installed in the EKS cluster. Now we are set with the stage. The next command is basically to evaluate the taints and tolerance. Okay, so for that case, what I do is, so here first one is, so we need to So basically we need to basically we need to now install the prerequisite here, right? So the prerequisite, so when I say prerequisite, so prerequisite is here, that is taints.yaml file. Okay, so for this case what happens is, now we install the Karpenter, so we need to install the Karpenter, the node pools groups, right? So we need to define the node pool that is orchestrated by the Karpenter. So for that sake, I have a file called taints.yaml file. It creates two objects called node pool and basically EC2 node classes. So don't worry so about this file. I'm going to share this file in the video's description. You can find it from there. So here, here it is creating a node pool with the certain definitions. It has a disruption, disruption definitions. It has a limit as well. And in the templates, you see that it has the labels. Remember, this is very important label, right? And then if I go down to the specifications, node class references, that is the default name. In the requirement, basically, the how the node pool should be created, right? So the node pool will be created out of these kind of definitions. That is nothing but the instance category should be from ECMR categories of EC2 instances, and architecture is from AMD 64. The capacity, it should be on demand, something like that, yeah. And the one selected here is nothing but kind of a center point of the this demo, right? So when I say center point is nothing but so here we are declaring the Karpenter node pools. So when you declare the Karpenter node pools, what we are doing is we are adding a taints on that node. If I go back to the diagram, so basically in the diagram you see that we are actually creating a node groups or node pool, but the nodes will be having a certain labels, and those labels are tagged as taints. So basically that is how we when we create a node groups, and you want to stop certain parts to be not to be scheduled on that the nodes, you do that with using a property called taints, right? And that taints will come under specifications, right? So you see that when you declare the specifications here, so we are declaring a taints with a key equal to system nodes and effect equal to no schedule, right? And this is what actually restrict the default pods to be not to be scheduled on this particular you know um, node group. So here the effect itself is no schedule, right? And that is where the impact will be happening, yeah. And the next the next object of the of this particular Karpenter is basically that is EC2 node classes. So here is we're actually declaring the EC2 node classes, yeah. Okay, so with this definitions, what we do is if I go back, so here we are applying that file, that is taints.yaml file. If you see here, so once we apply this taints.yaml file, it created this too. If you see here, it created a node pool and EC2 node classes. And then I'm creating the namespace, because namespace is needed for application deployment purpose. The namespace is workspace, the workshop, that is nothing but yeah, just a workshop. All right, the next one is let's go to the next file, that is no tolerance deployment. In the sense, now what I'm doing is I'm just deploying this particular I'm just deploying an example application, but it does not has any the tolerance to the taints. Remember that we created the Karpenter node pools with a certain taints. Now on the other side, we are actually deploying the application that does not has a tolerance to that particular taints, right? So which means that the pods should go in a hanging mode. In the sense, these pods at least should not be scheduled on the node pool created by the Karpenter, right? So here this is an example application that is nothing but a deployment, all right? So deployment, remember that in Kubernetes world, it is an application deployment or pod creation process. Metadata equal to name. So basis metadata will contain two types, name and namespace. Then the replica. So we are actually creating a 3 replicas, and the selector is basically app inflate template. This is the template. In the specification, you see that. So we are actually specifying the container name and the path, basically the image path or basically image URL, and then the node selector. Remember that. So I'm purposefully saying that hey, this pod has to be scheduled on the nodes that is created out of Karpenter node pool group. So how does that happens? If I go to the taints.yaml file, so here we are actually labeling them, right? So if I go to the above, so here is the label. So we are giving the label called EKS immersion team, right? And that is what it actually creates a node pool. In the sense, it creates a node pools, and each nodes will be tagged something like that. And that is what we are declaring, right? So now, if I go above, okay, so with that, we deployed the application here. So follow my selection so that you understand. And then I suddenly run a command that is kubectl namespace Karpenter get all logs. Yeah. And I was studying the logs. In the logs, it does not tells anything about the it does not tells anything about is there any the event or request from the Karpenter to create a new the new nodes, right? So there is no such thing is happening, because even though I have scheduled 3 parts. Okay, so we can also check the status of the pods now. Let's check the status of the pods that we deployed without tolerance. kubectl get nodes namespace workshop. So if I type this command, that is kubectl get nodes workshop, if you see here, so basically workshop, so it has the so yeah, it's not a no namespace, it's pods. kubectl get pods. Let's get the pods that we have created now. Let's see what is the status of those pods. You see here you go, right? So basically what is the happening here is, so we have created an application, we deployed an application, or basically created the pods. But if we here there we are telling that this pod has to be deployed on the nodes which are having it, the labels which should have the labels like the EKS immersion team is equal to my team. So it means that those nodes should have a label something like this. Yeah. But on those nodes, on the other side, we have declared those nodes as a taints, which means nobody should schedule the pod on those nodes, right? Now, how to overcome this kind of situation? So that overcoming of the situation is nothing but tolerance. Okay, so for that case, I have another file which is basically same replica of that. Whatever I have walked through, it is the same deployment file itself. That is deployment. You see that, right? So even it is pointing to the same image, right? But here only one difference that you see here is, if I can open this file as well and this file as well. So difference is in the tolerance. In no tolerance, you don't find anything after CPU. Here after CPU, you will find that in the container definition. So if I minimize this, underneath the specification parallel to the container, you have a tolerance definition as well. So tolerance is that, so if there are any taints with the name like system nodes, right, operator equal to exist and effect equal to no schedule, then make this particular deployment to happen on there. So something like that. Yeah. So now what we do is we try to try to deploy this again, right? So let's try to deploy this particular file there. So how do we do is, basically we need to run this command, that is taints. So file name is taint deploy. So let's deploy with this tolerance definition. So now what we are doing is we are actually deploying an application that has a tolerance definitions as well. Now if I do the the get pods again, now it will basically what happens, it will start scheduling, it will start it will not happen over the time. Basically it will not happen as soon as possible, because because now what happens is, Karpenter will listen that yes, there is a pods which are listening, and those pods has the basically has a proper tolerance definition, so that it can schedule on this particular node, something like that. Yeah. So let's see, how does we see some nodes getting created from the Karpenter. That is what the expectation here. So to see the logs of the the Karpenter, you can run the command, that is kubectl namespace Karpenter command. So I'm doing it here in front of you so that we can see the logs properly. So if you see here, so basically we should see a message saying like there is a request for a node. Okay, something like that. Could not schedule the part. You see that, these are the earlier messages that could not schedule the part because of the because of the the tolerance definition, something like that. Yeah. Now if I try to refresh it, basically you should be able to see the the latest message. So if you see here the latest message, starting matrix something like this, then you see that could not schedule is there, no instance specified is there, right? So it's basically it will take the time, but it will come back to the it will basically the carpenter will try to create the nodes in within few seconds. Okay, maybe what we can do is we can go back to the the cluster, the Kubernetes cluster here, and go to the EC2 machines. Here you can see that the number of EC2 machines gets drastically increased, in the sense you can see that the carpenter will try to create the the nodes according to the node pool definitions. So basically by default the cluster has two nodes. Now we should be able to see that the another node pool should be the another node should be created in a while. All right, so meanwhile, while it takes certain time, what I do is I'm going to go on a pause and come back in a minute. Okay, so after waiting few minutes, I'm doing a certain troubleshooting step here. So when I say troubleshooting step, right, so let me quickly tell you what did I do as a troubleshooting step here. In the taint.yaml file, where it actually creates the Karpenter node pool and the EC2 node class. So here I forgot to give the cluster name, right? So wherever I have selected the cluster name called Karpenter -demo, so I didn't replace that, and I have deployed that resource in the Kubernetes cluster, and that's the reason it was not invoking the the node creation task in the cluster, right? So once I did that and redeployed, if I show you it again, so if I scroll up a little bit, so here after the fix, I did run a command that is kubectl apply taint.yaml file, which creates the node pool and EC2 node classes, and then it that is scanning the Karpenter logs. In the Karpenter logs, I see that error, that is could not schedule this part because there is no tolerance definition being defined on the pods. Okay, and then I just run the command that is called kubectl get pods from the workspace, from the workshop namespace. All are in pending state, right? And then later so then later again I rerun the command that is basically taint.deploy. So taint.deploy is the file which just now I have walked you through, where it has a tolerance definition that is something defined here, right? So after deploying that, what happens is if you see here, right, so now instead of 3, now 4, the 4 parts gone in a pending state. And then suddenly after a certain time, after a couple of minutes, if I rerun the same command, that is get pods, you see that one of the pod is now in running. So that is does not happens over the magic, because it happens because so because Carpenter has spinned up a node according to the tolerance definitions. Okay, so if I get the logs of the Carpenter, you should see that the node creation request has been come something related logs, right? All right, so you see that found the provisionable pod, something like this, and you should see the message that is the node creation message is being done. Okay, so on top of this one, you can also always feel free to go back to the AWS the AWS console and try to refresh it. You should see that instead of default 2, you should see like the 5 instances are getting created right now, right? So the instances are nothing but these are all my Kubernetes nodes basically, right? So these are all the 2 nodes being created during EKS process creation, while other 3 nodes are being created just now, right? So if I go to the EKS service again and go back to the clusters here, so this is my cluster, right? So what happens is the Carpenter has responded to the tolerance definition, and it is has tried to create basically it created the nodes and it scheduled those unscheduled the pods on that newly created node. Yeah, so if I again try to get the pods from the workshop, here you go, right? So you see that all of our pods are now running, right? So don't get confused here, because when I was running this command, so that was the fresh command, so it was getting the data from the cache, while it actually had only 3 parts of the application, right? So I have walked you through the definition of no tolerance deployed definition and taint definition. Basically both are same file only, and so and they all the both the files contain the replica. The only difference is so the taint deploy.yaml file had the tolerance definition, and that's where from where the nodes know from where the pods got capability to get scheduled on the the Carpenter nodes. Okay, so in general, so you have seen that so how does that the taints and tolerance concept works in the EKS cluster, or basically Kubernetes cluster. All right. So with that note, thank you very much for watching my videos. Can request please to subscribe my channel. That would really encourage me a lot. With that note, thank you. Thanks a lot, and see you in the next video.